Good afternoon, everybody. Good afternoon! That's much better. I'm Chloe Arson. I'm from Georgia Tech, and I'm going to talk about an education configurator for different mindsets. That sounds a little bit mysterious. So here's a mental picture of our vision. Our first postulate is that we think that everybody thinks differently. Every talent can be hidden into different kinds of aptitude. However, we have common expectations for the engineer of tomorrow. So our thinking is that in a perfect world, academia could be this tree that is able to detect different levels of aptitudes and different backgrounds, conventional and non-conventional students, students from underrepresented groups that may be very deep somewhere that we do not really know. And academia is that trunk that gives a common skill set to this population towards a set of competencies that all bring us to the perfect engineer. So as you can see, all of these branches are alive and are one way of expression of a good engineer. And of course, by the process of doing so, it may well be that one of these branches is spreading a seed that gives birth to another school of thinking, therefore the other tree. So how do we materialize that? Our thinking is that we could potentially create a framework that would allow students to get their degree in a much more flexible fashion. The idea would be that you have a set of competencies to acquire, and that could include technical competencies as well as creative thinking, as well as different ways of producing added value, say a patent, an abstract, or something like this, life experiences. And to achieve this set of competencies at different levels of mastery, you could do that at different paces and using different pathways. So here is an example of several students who may have different mindsets and different ways of thinking, different ways to approach problems. And our goal as academic scholars is to bring them all to this set of ILOs, and I can't remember what that stands for.
Intended learning outcome or intended learning objective.
Thanks. Obviously, my mindset is not into acronyms. So we want to cultivate these pathways, and here's us. So you saw this incoming population of students that we're going to not pipeline, but rather reach out by networking through multiple routes. And the school is this trunk that you can see around a cross-sectional view here. At school, you're in this common trunk that will give birth to different branches in which we will cultivate a set of skills that go towards mindset, technical skills, project management skills, communication skills, and global visions. For each of these kind of competencies, we'll have a hierarchical scale, like a Bloom's taxonomy, and maybe we can illustrate that here. So this was a cross-sectional view of the tree. So you have the horizontal view. Now here's the vertical view of it. So
I'm working on it.
Imagine that your incoming population of students is here through the roots, and you have level 1 of competencies. So this is still the cross-sectional view of my tree with the different circles of competencies. You have maybe here the descriptive level of knowledge. All of a sudden you have analysis, and maybe here you have evaluation. And everybody's different, is going to take a different path. You can move to the left, move to the right, and being very curvilinear. And along the way, you're going to hit your target of knowledge at different points according to different vectors, because obviously you're pumping out different courses at the same time. You're doing different activities at the same time. Right? What's the next slide? Yeah, so here is the, yeah, and we need to do speed. We forgot that one here.
We're a little,
Level 1's still there.
we're a little slow on the speed.
So the model that we're proposing is first define what we think is an engineer. What are the competencies that we're expecting? Of course, there are a set of technical skills that we're expecting. Let's say, draw a free body diagram, be able to project vectors. There's also a set of life experiences that we're expecting our students to have, like some knowledge of community service, some knowledge of global experiences. There are creativity activities that you may be part of. There are also some industrial products that you may want to be involved in. For each of these rubrics, we're going to define criteria to evaluate their value and examples, so that this model will be transferable to any institution depending on the way they work, on the staff they have, and of course that will allow each institution to develop the idea at different scales progressively. Say, you may want to establish the system only for coursework first, then incorporate associative activities in there and have some faculty members involved in assessing associative work, like maybe fundraising things or things like this. And that will also allow students to achieve their learning goals at different speeds. Say you can grow very, very fast. This is probably typically a green bean or a radish of some sort.
Correct.
Now, if you're a cypress, maybe you'll go very slow. And academia is us, this set of constant gardeners, keeping track of every kind of student. The expected deliverable is this. So, going back to our title, the education configurator for different mindsets. What's in black is the initial mindset. So we model a student by its population of neurons. So not everybody has the same space distribution of neurons. Some of them may almost conflict with each other. That's typically me when I'm driving. And academia is what connects the dots for a given purpose. So note that we're not, the intent here is not to connect all the neurons, because we want to produce engineers, not lawyers, right? So certain aptitudes may be set aside for what we want to do. And we have different connections possible. Some of them may be purely technical, others may be creative, the green ones, for example. Others may be decision-making. Some links will be stronger than others, but at the end of the day, what we want to produce is a graph that has certain mathematical characteristics, such as sustainability. For example, if I cut this connection, I'm still able to make a connection between this neuron and that one because I have this duplicated connection. So if you model the product of our training, that would be this graph that has these several mathematical descriptors, and that would describe really well what we think is a good engineer. So, and we hope with this that it will allow a broad population of students with different ways of different mindsets to be more flexible in time, more flexible in scale, at the individual scale, at the class scale, at the curriculum level, and at the university level, to develop the engineer of tomorrow.
Thank you. Thank you.
So we were trying to decide if our team name was going to be Educational Terrorists or Educational Anarchists. And conveniently, we landed on Configurators is the nice way to say it. Cassandra had a question, I believe. Oh.
So I think you're in lots of ways preaching to the choir. This is great, and I love the idea of like a more customizable, individualized path. And I wonder if you gave any thought to how to preach not to the choir. Like I'm concerned that many of our faculty colleagues back at our home institutions might not even have the vocabulary to have that conversation. So have you thought about how to try and communicate to the rest of the faculty about this sort of thing?
Yes, it's hard.
Also, and we talked about that a little bit. I think that this symposium right now is a good example of creating new ideas from different places who may not have yet the language to express them. So maybe one way to go around the issue that you're mentioning is to create this network of scholars and make sure that all the trees that are developed in the landscape of academia get connected so that we can assess each other, provide each other some feedback, and be stronger, because of course we'll have obstacles. Some deans will say no, and we want to be constantly motivated by role models. So I think the key here is networking.
Sorry, not trying to take. I think the other piece that we discussed with this was looking at all of the projects that we originally came in with, was that they were all at a lot of different scales, and that the demonstration of these different pathways and competency building can be scaled in different ways. So maybe another approach is to start small, start with little things, and then try to build the network to grow, to continue to grow that to a much more expansive outcome.
Thanks for your question. Getting buy-in is the most difficult part here. I've been involved in two projects that are very similar to this. We never use the tree metaphor, and thanks to our moderator for having us follow that last electronic wizardry, because this was really good. What I found was that the traditionalists will fight tooth and nail and almost on an emotional level to maintain what they have. And so we were able to get it through. We did 100% project-based learning curriculum where students really didn't take what we'd call formal classes. We worked through that system. What I found now is that I went to another institution and started something similar, but what I found is that if you can show value, so when you imagine evaluating student performance, but do it in a way that creates value for both the faculty member and for the student. For example, one of the lower level values propositions would be writing a standard operating procedure for your lab. So they've gone through and done some activity. They write a standard operating procedure which makes your lab more. I started out with this, and I've been able to gain 4 or 5 faculty members to join that. So it's kind of a growing thing because they see a value in that. Students demonstrate learning competencies by writing an abstract for a refereed conference, for example. So once people see that there's a value in evaluating these students this way, then you can get some more buy-in. But it's a very difficult thing.
And I think to let you know that there's an NSF grant that at least one of our people was planning on applying to, and it's due December. And so if you guys want to be part of that network that starts to build those roots and detection sensors and beautiful imagery, then you could collaborate legitimately and do it in a couple of months.
I think one other thing is a lot of this we're already doing. So incorporating grand challenges into coursework, trying to do K-12 outreach, encouraging outreach from our students, sustainability, EWB, all these things, we're already doing it with the goal of incorporating this diversity. So it's really that we're putting all these pieces together instead of viewing them as separate activities, but trying to see how they integrate into the whole.
Okay, so I have a question. So when I think of competencies and things I tell my students are, there are a lot of skills, and that if you're not good enough at something, you should work to become good enough. But then there are the things that you excel at, and you should really focus on keeping excelling and finding that passion there. And so one of the things I think about is the nurse practitioner model. Not everyone has to be a doctor. You can be a nurse practitioner. And so when we talk about competencies, it sounds a little like we're waiting for everyone to earn an A, and then they have to go out all earning an A or all being the same competency. And do we want students to stay in school that long, or can we have something more flexible like the nurse practitioner model in engineering?
So we discussed competencies, not only just checking the box, but at what level do we want them to check the box on Bloom's taxonomy? Do all the students necessarily need to be creative for each one of these intended learning objectives at the end? Or do some students simply need to demonstrate the ability to understand some of those learning objectives, but be very creative at other learning objectives? So we're not going to get all of our students to be A students. We're not going to get all of our students to have the highest level of Bloom's taxonomy for each one of these intended learning objectives, but knowing that the students by the end can achieve these competencies at a variable level. That's different than simply just waiting for them to get a good enough grade to get what they're all seeking right now is the grade to pass the class and keep going on.
I love this model and I love this idea, but one of the things that might come back and I also wonder about is how do you get some of the very core fundamental concepts, and it may be because I haven't done project-based learning as much, but you know, the 2 + 2 = 4 fundamental, and how do you fit that in, and how do you see kind of ratios and
I think we did not really focus on project-based learning. That can be part of the activities that you do to reach to your level of competencies. But the key here is that we allow students to take different paths to get these competencies. Some people will be very good in class and be more comfortable in taking tests, formal tests, to get fundamental knowledge. Others will be more comfortable in a lab and will perform really well when you first give them the big picture and they see how to integrate the different pieces of the puzzle. So here the idea is more to develop this platform and give a map to the students, and then they decide what path they want to take.